Good to go.
All right, welcome everyone. Thanks for joining today's Tech Talk with the Tech Academy. Today we have Wesley and Rolfson, and they're going to talk about optimizing SQL Query. We do have a SQL course on our bootcamp. You might have already taken it or about to, so it's definitely going to be very informative. So thank you for joining us, and take it away.
And so thanks for having me, you guys. Just a little bit about myself. I am a data analyst. I work with a couple different companies as a consultant, and I've been really interested in how queries are formed and in the process going on in the background. All that whole piece that's an important piece of writing a good query. So without any further ado, we'll get started. So we're going to talk about the challenges of writing a good query, the 3 dimensions of SQL that people need to know about. What's the simple logic so we can understand it from a starting point, and then kind of go through some various pieces of a query. And I want it to be pretty interactive. So if you have questions or comments, feel free to, like they said, put it into the chat, and people are free to ask whatever, and we can work our way through this. First thing everyone needs is you're going to need a piece of paper and a pen. Even though this is an online presentation, there is an interactive section that will require you to do something. So please take a moment to figure that out while we continue on. Okay, so this is that step. So one of the things about writing good SQL queries is it's all about giving the right set of instructions the right time, and how you logically process that as a person is kind of how the SQL engine on the optimization level actually functions. And then it's going to try to figure out, based on your instructions, what it should do next. So if you have your piece of paper and you drew a horizontal line at 90 degrees to a vertical line, so you're going to draw 2 lines. And then you draw another vertical line parallel to the first vertical line that you already used. And if you go through all these steps, adding this horizontal line to the first one, touch it so that it touches the vertical line of the one you just placed, and then draw an angled line to come off the top corner. And then again, add another piece that's horizontal to that angled line. When you get clear to the bottom of these steps, there's a bunch of different solutions. And I actually asked my 6 and 8-year-old, and then of course I redrew it a little bit so that it was looks a little bit cleaner. You're gonna get a bunch of different answers depending on who it is. This is kind of how a SQL optimization engine can do it as well. It comes up with what it thinks you really wanted, and you get a bunch of different pictures. Well, which is the one that you wanted? Well, technically it's this chair. We were aiming for a chair, but because the instructions aren't very clear and computers don't do the same amount of logic that we can do, it might get a different answer than what you think. Your query might produce results that you weren't expecting, and that's why it's kind of important to understand your instructions and try to format them and think about them in the same way that it's going to do it. So that's kind of why I use this challenge, and it's a fun thing you can also do for other people to see kind of like what they'll do. But if you think about it from how SQL works, we wrote out it in lexicographic form. Like, here are the instructions. And then the next thing that happened is our brains took that information and said, okay, well, what do I do with that? How could I make this the most efficient? And it put together its own sequence of like, what does that mean? And then what you actually did, so the actual layer that the SQL engine generates, is the last step where you guys just draw a picture. And it looks like, it looks something similar to this. That's how SQL kind of works. So again, so it's 3 layers of a SQL query that we need to think about. The first one's lexical, and that's what you see on the screen right here. This is lexical form, and it's from top to bottom. That's how we write it usually. There's a couple things you can throw in there to change it, but that's the general idea of what a SQL query would look like. Then there's the logical step. After you click submit and it tries to run it, it puts it through a process inside of each of the different SQL engines that's called the optical or the logical layer, and it decides what you mean and kind of formats things differently. And then the last step is linear calculus applied to your logic that it generated from your lexical query. And so that's really complicated, and we're not going to go there because there's not really many of us who can understand, vector calculus and kind of go through the process of sorting out, like, why did it pick this over that? But what that really means is somewhere in there, there's multiple layers of processing to kind of make the thing that you wrote what it thinks would be the most efficient way of going and grabbing the data in the database and putting it in an order and fashion that looks like what you originally asked for. So we're really going to work on how to get from lexical to logical, because that's actually the easiest way for us to optimize our queries, and then just let the linear calculus do the rest. So first step is, these are a list of like the most commonly used terms. There's some languages have like different versions or different syntax or like how to call on something, but this is the general generic version of what a SQL query can include. And we want to get from, this is how we write it when we put it into our program, to how does the logical engine do it. And so the first thing that happens is we wrote this all out, but it actually only looks first at where we said to go get the data from, which kind of makes sense. That's what, if you were wanting to start from somewhere, this is a good place. This is where it starts. Where do you want me to go get the data? And then the second step, and these two can happen simultaneously because they're very related, is joining all of those tables that you just mentioned into one location that it's going to try to pull from. And so we'll talk a little bit about the join and the from and how to kind of work with that a little bit. After you do a join, it gets all that data, that it gathers all the data it wants to use or you've asked for. It then uses the where, and this is actually the first time where we actually have a good opportunity to optimize or reduce the amount of compute time or complexity of the data that we want to use. It's right here with the where clause. And this is just saying for each row, check to see if it meets a certain criteria. Like if we ask it to show me only a certain color out of a column, then it'll do that for us. But it's not really looking at all the data. It's looking at individual rows and either including or excluding them. So we can use this as our first chance to really limit the data that it's going to try to pull, which the goal being to reduce the amount of data that it's going to do anything else on next. So here we are. We've got a step where we can do that. And then group by is taking rows and grouping them into categories or groups, depending on how you want to talk about it. And once we get to group by, everything else after that has to do with aggregation and other ways of filtering by groups or by rows. So again, so now we're going to do aggregation. Typically, we see this showing up in the select, or we're going to use it in other parts of it. But this is kind of where it's going to go next when it's deciding how to process your query for you. And then having, does anybody know, like, what's the definition of having? Like, what is having actually talking about? I didn't see the chat go off. So having is about groups. You can, when you're making a having clause, you're talking about a group of something. So we'll look at that too. And then we finally get back to the first thing that we wrote, which was the select statement. And this is, again, the columns or features that we want to show in our table. And it's more of like a vertical orientation of the data. And then distinct. So inside of the select statement, we finally use the distinct. So at first it put all of the information that you asked for, every row, straight across, everything. And then when it got to the distinct, it kind of filtered again by just individual and unique like identifiers like names and people, things like that. And then the last thing that we really can use is order by. And that just says I want to see these in a specific order. And you can combine all these things to get that table that you're looking for. And the reason why top is the very, very last thing is top or limit, depending on which program you're in. It actually isn't doing anything to reduce the processing or the compute time necessary to do this query. It's just saying, after you've done all that other work, I really only care about the top so many rows or the bottom so many rows. And so it's not really a part of changing the logic or making it faster or better. It's just like someone took a pair of scissors and cut the table so that you're only seeing so much of it. But the data for the rest of it still had to get processed, so you didn't really save any time. And so congratulations. All of you guys have been promoted to the new technical recruiter for your company. And your job is to come up with who they're going to hire for this new position. He wants you, and he's got some criteria he's going to use to figure this out. So it took him a long time. He built a random number generator in Python. That did not work very well. Then he said, okay, we'll do pro-con lists. What are the things I like? What do I don't like? And he threw that thing into the blender. He was like, forget it. Then he just got a pair of fuzzy dice and just started rolling them. And he came up with criteria, which is a horrible way of doing this, but he's your boss, so you're going to do resets. Oh, sorry. So just based on that, simple logic, we're going to try to figure out like what kind of a query you might want. What is he thinking? Well, no matter what he says, the first step's not going to be to write down that huge list of stuff or the short list. It's going to actually be to start with, where does he want me to get that data from? So you'd have to ask him, like, okay, how do you want me to do this? Where should I get my data? Okay. And then what are the criteria that you want me to use to separate out all those people? And then most likely you're gonna have to come up with like some sort of like list table for him. So those three things are really the fundamental parts of a query, and we're gonna use those to determine our process. But before we do that, just want to go over quickly like the rest of the steps, like the joins and the group bys and aggregation and having, so that we have a good idea of like what we might want to use. Joins. So the first thing you need to know about a join is, in actuality, what we're really doing is, no matter which one I pick, it's taking all the data from two databases and combining them together based on like a unique ID. So the same, like in this table, you can see, they've got an omelet, a fried egg, a sausage, and the other one has orange juice, tea, and coffee. Well, it's going to take all the things from both tables and kind of combine them. So for every entry in the second list, it's going to put an omelet with it, and then it's going to put a fried egg, and then it's going to put a sausage. And then after it's done that, so this is why it's important to know what's actually happening. It then goes back through and decides, what did you ask? So joins are pretty computationally heavy and really complex and confusing for people, because the more we try to join things, the more complicated the joins are, the harder it is for us to write. And so when you're thinking about it, always try to remember, I think about it in groups of 2, because that's what it's doing. And so we should do the same thing just to kind of help ourselves. And here are the different kinds of joins. Anywhere where it's white, that means that it's not going to use that data. So an overlap between A and B completely is an outer join, and an inner join is only the data that exists in both. And then the rest of them are combinations of the two. Like the one directly above is a full outer join, which is a lot like the one above it, but there's one little difference. This time we're saying anytime where we're adding a where clause, if it's null, don't use, or if it's null, don't use them. So that's one thing to just remember. There are some additional, where clauses we can use to help the joins, but for the most part, this is the join table that we can use. Yeah, I'll add the slides and send it to the tech people so they can distribute them for you guys. Also, there's some resources we can point you to. So when you're looking at complex joins, try to see them as pairs, like I said, and then try to organize them in something called chiastic order. And that's just because when you start looking at all these diagrams, it can be a little bit more confusing and trying to figure out, how do I write the one on the left? How do I write the one on the right? And the way we can do that is using a style of both visually and logically thinking about them in terms of the pairs. So when you look at this one on the right, I have 2 choices. I can join B to A first, or I can join A to C first. So, and in this example, it goes all the way down to a fourth table. We don't have to do that. We can just have the first 2. So that would be, so if we just do the green and the blue, that is this desired result. We can do that fairly easily. And the result is actually this final one over here when I do that. So if you have questions about joins really should be its own topic all of its own, because it's pretty complex. But just know that the idea, when you write it, you should try to write it in this format where you're tabbing in and you really just focus on one table joining with another table, and then what's the result from that? That's your new table to join with another table. So we're never really looking at it in as a whole picture, but only in little steps, which 2 tables get joined, and then that new table we make joins another table. And that helps us get through the logic of that. So again, we're using where as our net. Yes. Yes, Sherry, yes. So where is how we eliminate as many rows as we can based on values in a column. So, and since it comes right after we've done the from and the join, it's a good point to start filtering data back out, especially if we've done a join. This is another good spot to try to reduce and limit as much of the data as possible. So when you're building your queries, this is a crucial step. And you can put as many where clauses as you want by connecting with words like and or, and you can use parentheses to help assist with that as well, to kind of be more clear about the combination you're trying to make. Another thing you really need to pay attention to is null values. A lot of times different applications use different meanings for what null is. It can either be unknown or just not applicable or blank. And so those can have a big effect on your where clause. You need to pay attention to which one your specific program means when it uses it. Then the other thing you need to know is you can't use aggregates or an alias like you can for the select statement. So you have to be very careful. And then using the where to filter and aggregate reduces the amount of information. So that's extremely true. Like this is the first point where we're going to funnel or filter down our data to the so we're only really looking at what we a smaller amount of data, and it makes the query go quicker, and also it's a lot more effective when you're trying to. So you don't have to build more complex queries later on. It simplifies it from this point on. We can remove as much data as possible. And we'll see examples of this. So this is an example of we can ask for both the total count and the name for each row. So if I put this in, yes, in the context of SQL, when we write queries, we like up to this point, when I say select name, I took the count out. If I put a where clause that says where country is United States or hair color is blonde, my entire query right then at that point gets simplified as far as computations are concerned, because we're able to tell it this to only grab rows to process from this point on that meet that criteria. Whereas if I don't use a where clause and I don't think about it at this point of from this standpoint, what I end up doing is I end up writing queries that get a little bit more complex as I'm trying to figure out how do I only include what I want. And when the processing engine gets to the where clause, it's already optimizing it to say like it doesn't go through the entire database another time trying to solve other problems that you've asked it. Like I want it when we get to like counts or sum, it only is counting or calculating aggregates for the rows that you give it using the where clause, rather than trying to do it all of the sums and then going back and removing something from the list, which is what we're trying to avoid. And then this is really more about the name and the count. You can't have this be in the same query. It won't work. So you have to do something a little different. So this would be a little bit more helpful. So select the city and the count from the attendees. So where the people are seeking a job, and then group by city. So now I can actually, since I used a group by, I can now actually use count. Before, the query doesn't know how to process the name of every city plus the count of every city. It would try to combine one city with all the counts of every city, and it wouldn't work. So if you're going to do an aggregate, you have to use a group by. And then having is, so a lot of people struggle with this one. Having has to do with group bys, or a group that allows us to do things like ask all of the cities who have an average. So you'll see with having, you see it'll say having and then some sort of aggregation, like having sum, having average, having count. Where the where clause says where specific column, where ID, where name, where color, and those two, you have to remember which one uses which, and it's important for when you're formulating your queries. And again, it's if you can use any predicate, which usually is like a sum, average, count. And then, so here we are, we're down to select this. This is that list of things we want our table to include along the top row. And we have to pay attention to creating aliases, any aggregates that we want to use, and the filters and groupings we've already called upon earlier in the process. And then order by, again, this is how we can order the results that we get. And that doesn't necessarily mean that everything that we order by has to be used in the select statement, but it should be something that's referenced as a part of the data we're pulling. So you can't use a field that we haven't referenced as a part of a join. So if they can't use a field from another table that's not in the join. And another thing to think about is, this can be extremely helpful when you have a lot of duplicate names or IDs. Like if you were doing a list of people's names, if you were trying to sort all of the people who are named Adam, you might also add a tiebreaker that says like what city they live in or something else to help, lock in the order, so you know for sure it's always going to go Adams that were born after born in a specific year. So it'll always do Adam and then order of years they were born in, which that could be a huge help for your process. And then the last thing you have to know about order by is nulls get treated differently in order by depending on which version of SQL or program you're using for programming your SQL. Sometimes they're the first thing in the list, and sometimes they're the last thing in the list. And then the last thing to think about is, while the top and the limit don't really help your optimization in any way, they can be a way of limiting what people see. Although it'll be a lot more effective in what the word user would be like. It'd be a lot more effective to use where clauses or having clauses, or find a way to if you're trying to limit the number of results, to do it through the where clause, so that as your data changes, you're not having to go back in and change. Like if you said I wanted the top 3, well, maybe the top 3's has duplicates in it, and so you're getting like the first 3 rows are all have the same exact data in them. You're not going to get anything unique. So you might want to change it to use a where clause, where it would say like everything over a certain number or everything below a certain number I want to see. We can talk about that a little bit. This is the data that we can use to do our query for one of our examples. So for instance, for like if you were going to do like a limit or a top, if you were looking to do the top 3, you would get we get row ID 190, 191, 193. Well, those just happen to also be the people who signed up first. But maybe instead of saying top, we might say we want the 3 smallest sign up orders. So we could do where the sign up order is less than the min for sign up order, or -3. So you could come up with some criteria that allows us to always show us the top 3, even if the numbers change inside the sequence. We can always create some logic that would address that some way, or an expression. And you can use top to do that too, but it's kind of like finite. Maybe you want to be a little bit more dynamic in your coding. So our criteria. Your boss decided he likes them. He would not like it if they like the color yellow. So, and keeping in mind this list is a lot bigger. This is just a small sample of it, so we can see it on our screen. Doesn't like hamburgers. So if you like hamburgers, this guy is not going to hire you. He's also not going to hire you if you actually were interested. Remember, he's got his fuzzy dice, so who knows what he's thinking. And then he doesn't want you if you're not actually looking for a job. So at least he got one job related thing onto the list. He wants you to give him a table. So that's a good thing because we're going to do SQL querying. And these are the criteria for the things that he wants you to provide him. So I would like someone to volunteer. And then this is the name of the table. So like what, and you can put it in the chat, like what should our where clause or our, what should our from clause be? What should we use for our from clause? And then you can actually program it. Any volunteers for what the from clause should be? Yeah, presentation. We should put in presentation, from presentation. Okay, and then so the next step, do we need to do any joins? No joins. There's no other tables, so we're good. A where clause, it's a little complicated. So what is one of the where clauses criteria that we want to use? And there's 4 of them. So see what people come up with. Yep, fave color. So yep. We want to make sure that we don't want hamburgers. We don't want yellow. And we don't really want them to be interested. We want all negative. So instead of equal, so, and because of the way that, you guys still see my screen?
Yeah, we can. Can you make
it bigger?
a little?
Just. How's that?
Looks good.
Okay. All right. Yeah. So we have our from clause, and we said we wanted our where. Okay. And we said, so we had fave food type today. We don't want it to be equal to yellow. That's another way. So another way of saying not, depending on which program you're in, is this guy. So either you have to type, and I happen to know this, that will not work for this one. You have to do it this way. That's how fiddle works. So not yellow. And then just to help with visual, we can put in fave color. I'm sorry, that was color. And favorite food to not equal hamburgers. Sad day. And then we don't want interested. So you can tell it not true, or you can look at the results that we were getting, and if I can see it down here. So anytime someone said that, blood. Oh. Not gonna let me do it. But anyway, you can see that it actually says false. So we can say, I wanted to say false. Not interested, and seeking should well job. So I hope it says job. That's what he wants. Okay. Is there anything else that we need from our list? Do we need having? We didn't do a group by, so we can't use a having. Anything else? For the sake of SQL logic, like learning about logic, we would still try to do everything through like joins or group bys or stuff. But yeah, you can use views to help. But as far as like SQL processing, a join would be there's no need to join. We don't have two tables, but if we did, we could. I would show you these guys that this example doesn't have a join in it. But the last thing we need is all those rows that we want. Those rows are attendee, fave color, fave food, fave code, sign up order. So attendee, fave food, fave color, and sign up. Can't see your, hold on, I gotta jump back to your chat message real quick. Where equals operator and which one is better? I don't really think it's gonna make a difference. We don't in this one we don't need to use like. Could use like. That's another thing we can talk about. If you have questions about like syntax, like when would you switch, like this term means not. We could also try to use the word not right here. Or if you couldn't figure it out and you didn't know what you should do and figure out what symbol it wants, you could also just do not. And that takes whatever the expression is and makes it the opposite of what it says. For simplicity of everything looking the same, I keep it like this. And you can always use is or is not as well. But this is the syntax that for the example that I built already. So I'm trying to stick to the one I use so I can so we can see the same thing. I think that's everything. And then one thing you have to know when you're writing inside of Fiddle is sometimes it can try to do the schema again. So always try to highlight the section you want to run. And I just ran both again, so it'll be fun. So we can see out of all those people, and there's a lot, it made us a list of people who do not like yellow, or who did not say they like yellow, who didn't choose hamburgers as their favorite food, and we sort of got them in order based on the sign up order, but we don't. That's not really a guarantee that it's always going to be the case. So we want to do one last thing. We want to say that we want to sort it by something. So in SQL, order by is how we sort. So I'm going to say, and we don't even have to use one of the ones we use. So we could say by signed up. And then we have to tell it what order we want it in. Now, I didn't use signed up anywhere in here, but it's still going to do it. So it doesn't actually have to be one of the ones you use. It just has to be one of the ones on the table that I called upon. And then if we wanted to be extra sure, we could also add in, I want to make sure that if for some reason they signed up at the same exact time, we're going to sort it by alphabetical order of their favorite color. This time we're going to sort it the other direction. So it'll be Z to A. Go ahead, Bharat.
Well, we actually have the mics muted right now.
Get to type into the chat for us.
Yeah, go ahead and type it in the chat with your question, Bharat. So, and Wesley, that DB Fiddle is a good place to practice queries, eh?
Yeah, I typically I normally have this hosted on dbfiddle.uk, but I couldn't get it to work there, so I had to use this one. But yeah, I like this one a lot. It's really easy, and one of the things that's nice is it is running the setting up of the table like in this session I'm in with it. So if I want, I can change the data or use less or more. So like if I didn't have as much, I can type my own in. But if you have large databases you want to work with, you want to do lots of joins or do anything really big, it's still possible. You just kind of have to like shrink your data down a little bit more so it can process it. And since you are using a cloud-based server somewhere, if you don't have pro subscription, you have to keep your database small. So there's only 341 rows in this one, just to make it go quick. But I do like it, and it's a good place to test things. I also use like Snowflake. I'll do stuff in Snowflake just because, again, it's the same idea. You can build complex queries, and if you get more data, then you have 30 days of your free subscription to do as much as you want. So if you're just starting to learn and you want to practice doing some more complex stuff, you can go find things like Snowflake. And also it's good for a resume builder. Like if you wanted to learn about Snowflake or some other program, you can try to find their trial and really test their environment by putting larger databases in and doing the complex joins. And so I kind of recommend that too.
Everyone has a trial.
Exactly, and you should use them, especially if you're trying to figure out like what's the difference between Oracle, MySQL, Postgre. Just create a trial and go explore. Because like I said, the null thing nulls are always handled interesting ways. So right, you said where job equals X or job equals. I don't really see people do job like and using some that's like sort of like using regex, but yeah, you could if you know all of the shortcuts for symbols, you can do that, and I think that's a great example. But to keep it simple for people who are learning SQL, left out all those kinds of things. But like the simple formatting, the simple syntax, using and clause. You could also have done an or clause. And or just says whatever comes after this. So technically this and is going to complicate things. So once I put an or in here, I have to do something different. I have to tell it I want to include, and let's say that we do. My boss is going to get really mad because I'm breaking his table and it's not going to produce what he wants. But for learning purposes, as soon as I put this parentheses here, now I'm saying I don't want it to be yellow. I don't want it to be hamburgers. Or they need to not or so there's two. So we have two different groups of people now. We have the people who don't like hamburgers and don't like yellow, and then we also have people who aren't interested and are seeking a job. So someone could fall into both of those groups. This will include them. Before, we were able to pick. You had to hit each of the criteria. You had to hit every single one of them. And this time, what I'm saying is, if you're in either of those groups, then you're good, and we're going to put you on our list. So we should see our count go up because there's more people who maybe weren't interested, and so basically any one of these two, if you're in either of these groups, you're going to get included. Before, you had to be in the bigger group of all this criteria. Does that make sense? I think it's just when I put the or clause in there, I essentially now have two different groups of people that I can include, and there should be more people in the overall list when I'm done. So you can use things like that, and the parentheses really helps sort out what you mean. If you're not going to do, I would not recommend putting an or in the middle unless you're intending to do something like this. I would put the or clear at the very end if you only wanted to do interested, because it will go down the line and hit each of the criteria and then try to include it or exclude it based on that. So that's that part. I'll take questions unless people want to try, and then I'll give you guys some other resources, places that I went to learn more about each of these little pieces that are interesting, and some other locations. So
Yeah, actually, the last question kind of is regarding that. So any real-time SQL scenarios to practice? I know you mentioned where earlier.
Yeah, so a good place to go to do some more real-time practice would be so like HackerRank. I think that's on my list. I think I took it off though because it's a little bit more complicated anymore. So HackerRank allows you to just, you can go through and learn about it all the way from the beginning through, advanced SQL. And they're a good resource. I actually really recommend going through programs sort of like what the Tech Academy does, where you have someone who mentors you, because one of the hardest parts of learning on your own is being able to hear the story, and interact with someone and have them help you. A lot of times, if it's good practice, because if you don't understand something inside of HackerRank, you can search for it, but it's a lot better to find someone else who can explain the rule that you're not getting or understanding. I think that having a mentor or someone who can walk you through it's a lot better. But there are resources like HackerRank. Like I said, if you go through SQL and Snowflake, or if you go through Oracle's tutorials, they'll walk you through a lot of their terms and how they do it, how to set it up. But again, it's always nice to have someone else. So like meetups and Tech Academy type things and other online learning opportunities, I think they're make it a lot easier. And then of course you can try to find books. I personally worked with a mentor to do it, to get a lot of the help. Yes, I'll make my browser more. So yeah, so DB Fiddle, if you even just Google DB Fiddle, there's a bunch of different ones. This is probably one of the better ones, and it'll bring up a lot of options. Like you can choose which language you want to use. Postgre being one of the more popular, along with MySQL. Also, if you want to practice the differences, obviously you can pick different versions. There's some advantages to the lower or the older versions, but as far as keeping your skills up, I would try to stay in the most advanced, like 13 and 8 instead of the other ones. The other thing is, the other side of SQL is learning how to make the tables and stuff. And this is another place to come try that, is places like this. It's actually easier to do it on DB Fiddle than it is to try to put it into like Snowflake. And then other place that I recommend, so go to the bottom. We basically go through my PowerPoint. Oh, yeah. YouTube, like watching someone do it. This gentleman is Dave, Database by Dave, or Database Dave. And these two are topics that I think a lot of people struggle with. So like having clause, the where, and the logical order. He talks a lot about why it's important to utilize these to help improve your optimization. And then also his video about joins, grouping, expressions, and having is pretty good. And like I said, this will be included in the Tech Academy is going to I'll send my slides to them and they can distribute them. Also, this whole video is available on YouTube, so you can come back and watch the video and talk about, find out what you wanted to refresh on. But again, DB Fiddle is really good. And then just finding the Snowflake and the Oracle and the MySQL. You can even, I think there's even a Google tutorial about how to do their version of the database, although I think those three would be probably the best to work with to start with. Any other questions? I have to switch my screen real quick to see, but yeah. You guys have any other questions for me?
Yes, there's a few other questions. So for a data analyst position, what are the skills needed that you need to acquire?
I would say SQL is pretty big on the list. Not every position I've had used SQL, but the logic and the being able to work with some of the SQL logic, that is the same. So like writing a where clause or a group by or the aggregation, those all use the same skill sets. And also being familiar with Excel. So I can do the same thing I just did in SQL. I can do a similar process inside of Excel, and being familiar with DAX, which is the sort of like the expression language that runs in the background of like Power BI, also could be helpful. The other thing I would do is I would find the companies or industries that you want to work in. And like if you're doing healthcare, you should really, learning SQL is going to be great, learning Excel is going to be great, but you should also try to learn their primary programming language, which right now I'm trying to think of. My wife's a nurse and she uses it all day. I can't think of it. Anyway, like they all chart in this very specific program, and you'd want to learn that. Try to get in on that kind of a language. In the industrial industries, they have their own like CMS, RMS programs, and they have their own reporting software. And so again, I would just really focus on like Excel, SQL, and then if you have time to learn something like Python or JavaScript, just because a lot of additional skills that can give you a leg up on other people comes from that. And then really exposure and experience getting on something like HackerRank or working with a mentor or someone, a program that can give you a good portfolio of visualization, data experience, and being able to tie in a lot of the different kinds of data analytics jobs you can do. Like some people make lots of visualizations. Some people do SQL querying. I do a lot of SQL querying right now, but in the past I've done a lot of Excel work. Fun project I've done, and then I'll talk about chaotic order. I built a model in Python using machine learning that helps ambulance companies prioritize where in their city would be the best place to send the ambulance when it goes back out from the hospital post again, based on like time of day, location, and recent staffing priorities. Like when COVID hit, like that went out the window, of course, because everyone went everywhere. But before that, you could really use it to like pinpoint like what parts of the cities are going to most likely have the next incident, so that the ambulance gets there quicker and people are less stressed about how long it takes. And chiastic order is kind of about like the pairing of when you're talking about joins, it's really about trying to write joins so that we always think about them in pairs. And so we make two tables, A and B, and when we join them together, however we do that, we make table C. That's going to be a new table, table C. Then if we want to do another join, or we realize that we need to, instead of thinking about it as A and B, now we just think of it as C. And then C is going to join with D. But when you draw it out and you write it out, you always write it so that it's like indented in, or some way of indicating. Pull up my slide. That is what it means, is how we visually and logically think about it. So this setup is chiastic order, thinking about it in these pairs. Like first I'm going to do C, and then I'm going to do B and C, D. Then I'm going to do B and C, and then I'm going to do A and B. And if I do that, if I think about it like this, I can, that tells me I need to use parentheses to do this operation, or if I can get away without doing that. So you can pay attention to the order of operation, that's the main thing with joins, is they get really confusing. So you write it and you think about it in this way.
Got it. Another question. So any experience with NoSQL databases? What are the advantages, disadvantages of SQL database system versus NoSQL, in your opinion?
Oh, and just my opinion. Okay, that's a big topic. So now I don't have a lot of experience using NoSQL. I understand a little bit about it in terms of but it's like a SQL database is really good for storing charts and tables of data. Like I have entries that come in a sequence, like it's sequential data, or I can organize it in that way. But if you're talking about like storing pictures don't really fit well into a SQL database. There's not really a great way. I can store data about a picture this way, but I can't store the picture that way. Or people might organize the databases inside of a data lake. A data lake is not SQL organized. It's NoSQL. It's just buckets of data that have been organized with something in it. And so that would be kind of the idea. So it still has a structure. It's just not structured like a table would be structured. That's the difference. I could be completely wrong about all of that. That's my understanding. So
yes. I think there's another one. So describe a fun project you worked on recently.
The ambulance, trying to organize the where to put your ambulances so that they go into the most effective part of town. But I see there's a question about will you clarify the importance of lexical to logical, which one's better? Well, lexical is how we write the SQL query. Logical is what happens in the background. So like I was saying, most people write the select statement first, and then they put the from, and then they write their where. What I'm suggesting is, and what I didn't do because I wanted to kind of let you guys see what does it look like. We wrote it in the order that we should write it, but instead of writing it like this, when I write a query, I put as statements, and I put, mine looks like this. So it doesn't, and instead of those being the actual labels from the table, it just might say like food. And so I stopped myself from even doing, I might write favorite color and favorite food, but I might do it but I would do this because and we'll just say that I come up with an alias, and this is called aliasing. So I know that when I'm done, like this won't run right now. It won't work. It won't let me actually do it. But what it forces me to do is, I know that I want something, and that guy said he wanted to know who attended. So I might write like attended, or he wanted to know what food they liked, and he wanted to know what color, and he wanted to know what sign up order they were in. I'll put that down because that reminds me I need to figure those out through joins or however I need to get there. But the first thing I'm actually going to do is say, where am I getting this data from? Do my joins, and then the where clauses, all the ways that I'm going to filter the data down so that it's what I want, or what they need. So I would immediately start writing out expressions, and do I be doing it one at a time? So I'd write this line, then I would go back up and fix whatever one I need to fix up here to make it work, and then comment out. So in this case, that's putting lines on there to make it stop. Well, it won't let me do this one because I need one more. And so then I would add select all, like a star or something, so I can run it. And then I would go back and fix each one. I go, so I can actually do each line. And then once you get all the where clauses, then go back and fill in anything else I need. And if you're thinking about it like the logical engine is going to do it, it helps make your query. First of all, it helps you keeps you from writing things that you shouldn't write up in the select to begin with. Forces you to write each of the different where clauses so that it actually works. As soon as I put stuff up here, now that I have stuff up here, the only way I can test this is if everything's functional. Like I said, so I might comment out all of this top part to only have a select all, but then I'm running it each line by line, checking to make sure it's doing what it's supposed to do. And by writing it this way, if for some reason something's not working, I have the ability to comment it out, although it's going to force me to put them all the way up each line. But in Snowflake, this works a little bit more freely. But yeah, this is the process of first writing from, then the where, and then going back and doing the rest. That's kind of the idea.
It's a good way to go logically through it. It's almost like a pseudo query.
Mm-hmm. Yeah.
Looks like we have one more question. When do you put join in if there are tables to join when writing the code?
Okay, so right now this one says test from presentation. Let's say that I needed to do a join with, I don't know, location. So we'll just do a join. You can put your join right here, join, and then whatever table, test dot location. And then you have to tell it on. And then I have to tell it what to, so if you have two tables and you're joining them, the only reason you should be joining them is because they have overlapping data. So like, let's say that like the attendee and the location both have the same information, like the name of the attendee and the name of the locate, and there's a location. The table's really about where they live, so call it the attendees table maybe. In the attendees table, so I'll have to change my location to attendees. if there's an ID for an attendant and there's an ID for attendant in presentation, I tell it the field from test.preparation and the field from test.attendant that equals each other, that's the one I'm joining on, and that looks like, I don't know, yeah. So I would say like test dot, and so I would also make an alias for this too, just to save myself some time. Whatever the field is, so attend ID, and then what's the same field in the other one? Hopefully it says attend ID on it, so I can tell the difference. Test.attendant attendant ID. So now it's telling it my from clause, and I put them together, but you can separate this onto another line if you needed to. Join this table to that table, and it's going to automatically do an outer join. It's going to join both tables, all the data that overlaps, and then it's going to fill in either table the thing that don't. This is the process of doing it, telling it which table and then joining on what field. And then typically what you see people do is they'll do an as and they'll shorten it so they don't have to do all the long written out version right here. But does that make sense?
Yeah, Laura asked the following question. Would you write the join first, where / conditional, and then select?
Yeah, I will write all of the from this. I consider this part of my from. So I consider that part of it because it's where did this data come from. So all of this gets joined. And now also you can't really call on fields. You shouldn't really be trying to write all the select and the where in advance, because whatever I do to name this, all these different tables I'm joining, I'm definitely not going to, if I'm writing this, I'm definitely not keeping that as this presentation. I might just make this as P. So now everywhere else in my query, I can just write P dot. So instead of writing P dot, this one right here would just be P dot attend. And this one, to change it, we pretend this is not a real table, so it won't work, but so I can't run it, but I can say as, and then I can make that one A. So now instead of having this huge thing, I just write A dot attend and P dot attend. This is more standard. So this is what you'd see. And I can't actually run this one because there's not another table to pull on. But if there was and there was one that was called attend, I would be able to join them. Because I didn't specify, it's going to immediately do a full outer join. If I specify a left, it's going to take all the records from the presentation table and look at the ones in the attend. And if there's a record that matches, if there's an ID that matches presentation table, then it'll include it. If it doesn't, it won't include any of the rest of the data from this attend table with it. And again, that's why joins should have their own topic, because it's left, there's a right, there's an inner, there's an outer, there's a lot of different kinds of joins, and understanding like when each one should get used. You could probably go for like an hour and a half, 2 hours just on all the complexities of how that would work, especially when you do nested joins, which, well, you have stochastic order.
Wow.
Got it. One last question. I know we're kind of like over time. So which tools are free for running SQL?
You can get PostgreSQL. So this is Postgre. That's what it's spelled like. SQL for free. You can use this DB fiddle for free. That is exactly, I learned on PostgreSQL. You can learn on MySQL, though they have free trials. But Postgre is free, and they're are limitations to each of the different languages that use SQL. You just kind of have to read the documentation. So someone's posting like, here's how to make this query work. You got to always try to put which version of SQL you're using, like Postgre, so you can get the right syntax for like it may not be top, it might say limit, it might not say insert into, it might say copy into, things like that. But yeah.
Got it. Well, thank you. Thank you so much for that informative presentation. Also, in the chat box, I put your LinkedIn in there in case anyone wants to network. And then I also put next week's Tech Talk in there from Meetup. We actually will have a recruiter coming in talking about how to land your first tech job. So it's going to be very informative, so join in. And then lastly, I also shared a link to our Tech Talk playlist on YouTube. This is recorded and we will post it later today. So thank you guys for joining. Thank you so much, Wesley. And have a good Friday, everyone. Yeah.
Yeah. Thanks, Wesley. Really good presentation. I like the way you showed your logical thinking for setting up the queries. I think that was pretty awesome.
Thank you. Thank you, guys. Have a good day, guys.
Thanks all. Have a good weekend.
Bye, guys.